Hello everyone, my name is Sajid Muntaziri and here we are with another tutorial on Grasshopper. Are you ready? Of course you are ready. Alright, let's get started. So, in this session, we want to create an attractive view by combining Grasshopper and Rhino. To start, I will enter the Grasshopper environment and type XYZ as always to bring in the construct point component, which will create a point, the pertinent origin for me. To increase the number of these points, I can use the range component. So I type range and bring the range component and connect it to the X input to generate multiple points. Now in the range component, I need a domain and a step value. For the domain, I can use range from 0 to 50. All right. So for this, I type 2 slash and 0 and then space and 250, which define the range between 0 and 50 for generating points. And then I can set it to 150, which will create more points within this range. Now, if I don't want these points to be arranged in a straight line, I can modify and change the range values and then apply it to Y and Z. For instance, I can take the numbers generated by the range component, apply the sign function to them, and then connect the result to the Z input. This will create a wavy pattern, but that's okay. I can also apply the sign values to the Y input, which will slightly curve the points. Now, if I want the points connected to the Y input to be mirrored or inverted, I can use the negative component. To do this, I type negative component and bring it and connect the sign output to it like this. And then link the result to Y like this. This ensures the points are symmetrically mirrored along the x-axis. Now I need to create the same arrangement at a higher elevation. To do this, I copy the entire setup like this and I use Ctrl plus C and Ctrl plus V and place it in a new section. In this case, I don't need the negative component anymore, so I can delete it and connect the sign output directed to Y like this to have it inverted in this way. To move these points upward, I can use the move component. So I type move, set the translation direction along the Z axis, and define the height using the unit Z component like this. I set the height to, let's say, for example, 7 will be okay, I think, which represents a building floor height. Since I no longer need the previous construct point, I can select and delete it. Ctrl plus Q to keep only the lower and upper rows of points. Now, if I want the upper row of points to also shift forward or backward along the y-axis, I can use another move component. So I bring in a second move component. So here I type it and connect its input to the output of the previous move. This time I want to move the points along the y-axis, so I use unit y component. I set the movement a value to, let's say, for example, 0.5 can be a good number, which applies a small shift along the y-axis. We no longer need the other move, so we select it and press Ctrl plus Q. If I want a greater displacement, I can increase the value. For example, setting it to 1.5. To extend the movement range, this creates a range from 0 to 10, as you can see, and you can change it slightly, giving more flexibility for adjustment. Next, I want to connect the lower points to their corresponding upper points. For this, I use the line STL. So I type it again. Line STL requires a set of start points. I use the initial construct point for this. By default, it extends all lines vertically along the z-axis, but I need them to follow the exact path between the lower and upper points. To achieve this, I create a direction vector using the vector 2pt. So I type it again. I type this component. I connect the lower points as the start points and the upper points as the end points, like this. This generates a vector that preciously connects each corresponding pair. I then connect their vector to the direction input of the line steel component to ensure the lines are correctly oriented. I set the line steel length to 9, but this can be adjusted. Additionally, I can extend these lines slightly beyond their original range if needed, allowing for parametric control over their height. And here you can change it pretty slightly, and also you can here change the height as you now to connect the upper and lower points with a series of curved lines. I first need to extract the start and end points of the line steel components. So I use end points component. Here I type it and I connect the line steel output to the end points component like this. This gives me the start and end points of each line separately. So for each one, we can bring an interpolate component and connect it to this part so it creates the like this. I connected it and it gives us the start line like this, and I make a copy of this, and now I apply another endpoint component to this part, so we have these lines in the upper part too. So for the lower section I want to apply sweep one rail, so I type it, I bring the sweep one component, I connect the curve to the sweep one input. The sweep requires a section profile, so I use a rectangle component to define the section. By default, the rectangle size is too big, so I can set the number, for example, 0.2 times 0.2. I apply these values to both the x and y direction. If needed, I can further increase the section size to make the sweep more prominent like this. For example, I guess here, let's say it will be better to use 0.5 will be ideal. To extrude the upper lines, I bring in the extrude component and connect the curves to its base input. Since the extrusion needs to happen along the y-axis, I use the unit y component and set the extrusion height. Here, let's say, for example, 10 can be ideal. So I type 10 and I can control it so easily with a number slider for flexibility. To give like this, I can change it so slightly. To give these lines thickness, there are two approaches: using the pipe component to create a tubular shape or extruding the line steel curves to form a solid volume. I choose extrusion and apply it. So here I type it and apply it to the line steel curves. For direction, I initially use unit Y. The value is too large here, so I can set it to 0.2, which I can adjust as needed. If the extrusion moves inward, I use the, let's say, negative component can be very useful here. So I type negative to reverse the direction, ensuring the thickness expands outward. To further refine the form, I apply another extrude. So here I type extrude, and after applying another extrude operation along the x-axis, it gives us a rectangle shape, and the output of this extrude operation becomes the input for another extrude, but this time along the x-axis. The extrusion amount is also too high, so I uh, set it to here, let's say 0.07 can be ideal. To adjust the position of the rails relative to the lower section, I use the move component. I type it and bring it and connect it to the final output and move and apply transformation along the y-axis exactly. So I bring unit y, and since the previous components are no longer needed, I select all of them and use Ctrl plus Q to hide them. The final output can be controlled by modifying the unit y. For example, setting it to 0.3 for a slight repositioning, and I can control it like this. Now that the profiles are properly placed, I no longer need previous extrusion, so I remove all of them with Ctrl plus Q, leaving only the latest modification. At this stage, I proceed with baking the necessary elements in Rhino. So I select and bake the move geometry, the first one here, and the next one is sweep, and the last one is the extrusion. And I can bake all of them like this by selecting and clicking using the mouse scroll, and after that for this one and for the last one. And I can switch to Rhino's interface where I can manually adjust and reposition the baked object. If I want to remove Grasshopper's preview, I simply close the Grasshopper window like this, leaving only the baked geometry visible. Now that the form is complete, switching the view to shaded mode gives a clearer representation to the final structure. The next steps will involve refining the model further in Rhino. The first step in Rhino is to flatten the back surface. So I hold Ctrl plus Shifts and select the corresponding edges and use this setpt command, and I choose to align them along the y-axis, ensuring straight back surface. Next, I use Alt plus click and drag on the blue axis of the gumball to create a copy. Like this, I create a copy of this part, and then I select the lower section and use setpt again. But this time, align the z axis, and I single click on the C plane. Then to connect this section to the top boundary, I bring this a little bit inside like this, and I perform an extrude curve. So I bring extrude curve operation and ensures the solid is yes also to generate a closed volume. Since it doesn't form a perfect solid yet, I use two boundary to select top edge, extending the extrusion preciously to the upper limit. For additional detailing, if needed, you can apply a contour operation to create a curtain wall effect in the back panel. Now I address the roof, which currently lacks thickness. I select it and use extrude surface again to give it a volume. I ensure solid again is yes to so that it forms a closed object. All right. Finally, I check the bottom section to ensure it aligns correctly. If necessary, I make minor adjustment to bring it slightly forward for a better fit. To ensure the model is centered, I make a slight adjustment like this by moving the structure forward. I add a floor using the rectangle 3-point tool. I click on the first edge, holding shift and select the second and third edge to define the base, like this. In the front view, I move the entire structure above the C-plane so that no part is below ground level. Checking in perspective view can show us a clear view of our model. For material application, I assign a wood texture to the front panel. I select all the necessary faces while holding Control to exclude the back faces. Then I right click on layer 1 and choose change object layer to move the selection into the active layer. In the material editor, for example, I apply a custom wood material, adjust its color to, let's say, here, for example, I choose dark brown and confirm the changes, switching to rendered mode. Here I switch to render mode. Sorry, I can verify how the material appears in the final scene. For the bottom edge, I use Ctrl plus Shift to select it and move it precisely onto C plane. So I choose shade here and Ctrl plus Shift and select the below part and put it on the C plane. If necessary, I apply an extrude surface. So here I apply extrude surface, as you can see, and aligning it with the back boundary for a thicker base. And finally, switching back to rendered mode, I observe the final outcome. So what should we call our final outcome? Parametric sinusoidal facade with alternating concave and convex Curves can be a good name. You can increase or decrease the thickness of the lower section, and one of the key aspects of this modeling is the inversion of the sine wave amplitude, where the upper part has indentation and the lower part has protrusions. These points are systematically connected in pairs using a steel line. Right, that is the end of our tutorial today. I hope you enjoyed this tutorial session and see you next time. Bye bye.